be sharing a brief introduction to volumetric analysis and its application in the food industry, especially in determining the salt content in processed food. Volumetric analysis, also known as titrimetric, is one of the most common and important techniques used in chemistry. Basically, it helps us find the unknown concentration of a substance by reacting in with a solution of known concentration. There are several types of volumetric analysis. First, acid-base titration, used to determine the concentration of acid or base. Second, redox titration, which involves oxidation reduction reaction. And finally, precipitation titration, like Mohr method, which is commonly used to detect chloride ions, such as the salt we find in food. Volumetric analysis have many advantages. It is precise and accurate for measuring concentrations, it uses simple equipment, and it's cost-effective. It can be done in a short amount of time and is perfect for quality control in various industries, including the food industry. So, why is this important in food? Well, in processed food, measuring the amount of salt is very important, not just for taste, but also for health monitoring and accurate food labeling. Too much salt can lead to health issues like high blood pressure. That's why methods like Mohr's titration are essential. They allow food companies to make sure their products are both safe and correctly labeled.
Now, let's take a look at the public health impact. The first one is health consequences. Salt analysis is critically important because excess sodium intake is a major public health concern. It is closely linked to hypertension, stroke, and cardiovascular disease, where it is affecting over 1.7 billion people worldwide. The second one is global action and consumer awareness. In response, many governments have introduced a sodium reduction policies that require food producers to monitor and limit salt contents in processed products. At the same time, consumers are becoming more aware of the health risks associated with salt and are actively seeking for a low sodium alternatives and transparent food labeling. And the last one is, why does it matter? Analytical methods like the Mohr's titration help ensure that food products meet regulatory standards and support the goal of producing safer, healthier food. These tools play a key role in promoting public health and informed consumer choices. Next, I will be presenting the theory behind salt content analysis and its importance. Salt or sodium chloride is commonly used in processed foods to enhance taste, texture, and preservation. However, excessive salt intake can be very harmful. The World Health Organization (WHO) recommends consuming less than 5 grams of salt per day to reduce the risk of chronic disease. Salt content in food can be measured using Mohr's method, which is a type of precipitation titration. In this method, silver nitrate (AgNO3) is added to a solution containing chloride ions. The silver ion will react with the chloride ion, which will form a white precipitate of silver chloride. After all chloride ions have been used up, the next drop of silver nitrate will react with the chromate indicator, which will form a brick red precipitate of silver chromate. This color change will mark the end point of the titration and allows for accurate calculation of salt content in the sample.
Let's move on to detailed methodology salt analysis in processed food. This experiment required 4 equipments, which are burette, volumetric pipettes, conical flasks, analytical balance, hot plate and magnetic stirrer, and filter paper. Then, reagents that we use are silver nitrate solution, potassium chromate indicator, sodium chloride, nitric acid, and distilled water. There are 3 sample preparation methods used in this experiment. Firstly, preparation method for solid foods such as chips, crackers, and processed meats. The procedure breaks down solid food structure through homogenizations, then uses hot water extraction to dissolve sodium salts. The 80 degrees Celsius temperature enhances extraction efficiency by increasing solubility and breaking down protein-salt interactions. Filtering removes insoluble particles and dilution to a fixed volume allows for accurate concentrations calculations. Second, preparation method for liquid foods such as soups and sauces. Since sodium is already dissolved in liquid foods, minimal preparation is needed. Simple dilutions reduce matrix effects and bring concentrations within analytical range. pH adjustment neutralizes acidic samples that might interfere with sodium measurement techniques. like flame photometry or ion selective electrodes. The third one is preparation for semi-solid foods, for example, cheese and processed breads. This method addresses the challenge of extracting sodium from protein-fat matrices. Warm water helps dissolve sodium while the moderate temperature prevents protein denaturations that could trap sodium. The washing step ensures complete recovery of extracted sodium, and combining all aqueous fractions maximize yield. Next, standardizations of silver nitrate. This establishes exact concentrations of the silver nitrate titrant using pure sodium chloride as a primary standard. The sodium chloride is dried to remove moisture, then dissolve and titrate with silver nitrate using potassium dichromate as indicator. The endpoint occurs when excess silver ion reacts with chromate to form brick red silver chromate precipitate after all chloride has been consumed. The calculation determines the precise molarity needed for accurate sample analysis. Now we proceed to the sample analysis procedure. First, 25 ml prepared sample was pipetted into conical flask. Second, 25 ml distilled water was added. Third, pH was adjusted to 7 until 10 with dilute sodium hydroxide if needed. Fourth, 1 ml potassium dichromate indicator solution was added. Fifth, the solution was titrated with standardized silver nitrate solutions. Sixth, titration was continued until persistent brick red precipitate was formed. Seventh, burette reading was recorded to nearest 0.05 ml. And lastly, analysis was repeated in triplicate. For calculations, there are three formulae used in this experiment. First, chloride content, second, for salt content, and lastly, sodium content. Here's an example analysis for sample results. The highest salt content in processed food are instant noodles, followed by deli ham and potato chips. Meanwhile, the lowest one is canned soup, followed by frozen pizza and processed cheese.
In conclusion, there are three impacts that we analyze from this study. First of all, from the economic significance, the salt concentration plays an important role in enhancing the flavor and safety of processed food. The appropriate salt levels are also essential for preserving quality and ensuring the safety of processed food. Second, the impact to public health. The accurate salt determination can prevent cardiovascular disease. We can take the initiative to support the global health on targeting sodium reduction to prevent non-communicable disease. The last one, from the technological evolution. The fundamental principles remain unchanged. Integration with automated systems and digital technologies continues to be more precise and efficient. Next is for the future recommendation. There are a lot of future recommendations that we would like to share with you, but unfortunately for today we can only share three of it. For the first one is the analytical advancement, like multi-analyte methods, which is the determination of sodium, potassium, and other electrolytes at the same time. And another one is the green chemistry, where we use environmentally friendly reagents. The second recommendation is the industry trend. You can personalize your own nutrition like a customization sodium content depending on your preferences. And the global harmonization, where this method becomes a standard across international markets. And the last one is the societal impacts. This analytical technique really extends far beyond laboratory wall in our modern era. This scientific principle serves us as the backbone of industrial quality and public health protection for generations.